Why is the back for?
Normal places. Hurry, hurry. Quickly, quickly. Come on, come on. Righto, ladies and gents, let's go back over yesterday. We talked about elements in the periodic table. We said that elements are matter. They are therefore composed of? They're therefore composed of particles. These particles are called? Molecules. These molecules are made of, okay, joined together by chemical bonds. Okay. Because elements are a pure substance,
Same.
all molecules are
Same.
the same. We said yesterday in elements, what are the particles inside the molecules? Are called atoms. Inside the molecule are the particles. What about the particles?
They're all the same.
They're the same. And we gave some examples. The examples we gave were these ones here, in which there were?
3x.
No, there were. These indicate? These indicate? No, what are these? They're the molecules. Indicated that inside the molecule there is only one atom. Those kind of molecules are referred to as being monatomic. In these ones here there are two atoms inside the molecule, and these ones are referred to as being diatomic. These indicate the Y's indicate the atoms. This line here indicates the chemical bond. And what exists between this molecule here and this molecule here? Some kind of, not a strong chemical bond, but a different kind of bond that joins molecules together. What do we break when we melt an element?
The bond.
We break, which bonds we break? The ones inside or the ones between? The ones between. These ones here have got 4 atoms inside the molecule, and therefore are called polyatomic. Poly the parrot, isn't it? So these are righto. What we've also got are elements that have got huge numbers of atoms inside each molecule, and they're going to be the metals. Okay, what we need to do is to go back to the periodic table from yesterday, and we come down here. Not a good spot for it, is it? I better bring that up the front. I thought you'd be further down. We said yesterday that these elements over here are non-metals. They're the ones with one atom, they're gases, one atom in the molecule. These ones have 2 atoms in the molecule. These ones here are polyatomic with small numbers, P4 and S8, right? These are the non-metals, but carbon has got lots of atoms inside the molecule. All these ones over here are shiny, and these ones over here are the other metals. What we need to do now, and this is what this lesson's about, I want you to be able to find ways of distinguishing between metals and non-metals, right? And there are 2 ways of doing it. Elements have physical properties, which we'll be talking about in the future, but elements also have chemical properties. So we're going to look at the chemical properties of 2 non-metals, those 2 there, phosphorus and sulfur, and we're going to look at a chemical property of this one here, which is magnesium, and this one here, which is iron, right? And the chemical property we're going to learn about is what happens when we burn them and then dissolve the product in water. Is that fair? Okay. And the only way we're going to do that is by?
Experimenting?
Is by experiment. I can't tell you about it. You can only find out if you learn it. Now once we do it, you've got a problem. The problem is that you have to write it down in a form that you understand, right? So not only do we have to do the experiment and watch me do a demonstration over there, you have to write it down in a form that you understand. Okay? That's good for you. And we'll put a summary on the blackboard. So what I'd like you to do, we've got 1, 2, 3, 4, 5 groups. So what I'd like you to do is to get one of these trays and bring it back to your bench, please. So can one person from this side pick up the trays and take one for this bench and one for that one, please. What flame have I got it on?
Safety.
It's on the safety flame. Pardon? We'll get that one in a sec. We need to share one between 2. Okay. We're not.
We need water.
Oh, you'll have to share the. I've got one lot of water from between the 2. Okay. Now, what we're going to do is to burn some magnesium. The magnesium is this piece, the piece of wire. Magnesium is a very active metal and it burns very, very easily. Iron is not an active metal. If I used a piece of iron like that, I couldn't get it to burn. What I've got to use is a piece of iron which is steel wool, which is very finely divided, and then it will burn. I'm not going to be able to make it happen with that flame, am I? So what flame we're going to have to change it to? So when we do the heating, we change it to the blue, right? Second thing, magnesium burns with a very, very bright flame. You don't stare at it, right? You can look and watch the flame, but don't stare at it. If you do, it can hurt your eyes a little bit, right? It also burns very hot. If it burns very hot, what I don't want you to do is touch it, right? So in order to do that, I've given you a pair of wooden tongs, right? No, when you put it in there, I've fold it over, so it makes a double piece like that, right? Now, you also have a little beaker. I want you to put some water in the beaker. That's too much. About that much. And a few drops of universal indicator in it. And you'll need to share the big beakers of water with the bench beside you. Right, put the universal indicator in now.
How many drops?
About 4 or 5. Pass the water over, please, ladies. Right. When you put the universal indicator in, the universal indicator will be that colour. Right? That indicates that the solution in there is neither acid nor alkaline, acid or basic. It is neutral. Okay? That's the green colour. Righto. A few drops. Now, next bit. I want you to turn the flame to the heating flame, away from the safety. You know how to do that. If you don't, you've forgotten from last year. Turn the air hole, put the magnesium in the flame. Right. Once it starts to burn, look away and bring it over and put it over the top of the beaker. Right? No, the little one, the one with the stuff in it. Yep. Once it's all burnt, put it, drop it, just unclip it and put it in. Has there been a change in colour?
Yeah, it went a brighter green.
A brighter green? I wouldn't have called it a brighter green. It's gone a bit. We're going to leave it there. Oh, hang on, let's stop. Didn't burn it all. You panicked. Goodness gracious. Panic merchants. What a chemist. I'm going to get a migraine tomorrow from this because the flames hurt my eyes. Okay, now, ladies and gents, let's stop for a sec. Are we all done? We all done? I know that. Have we burnt the magnesium? Have we put it into the solution? What colour has the solution gone? It's gone a blue colour, right? Let it stand for a little while, and as it stands it will go blue. So let it stand for a little while, right? The one that I did work, look. Right, the one that I did work, it's gone a blue colour. What does that indicate? Did it say? It's alkaline. Yep, that's just fine. Okay, can you come back, just you sit down please? No, whoops. That's all right. Hold it up, hold it up, hold it up. Let it burn, move it forward a bit. Move it forward. Now let it drop. Let it drop. Good boy. Okay. Let it stand for a little while. What? To me, please. Magnesium's combined with oxygen in the air to form a new compound called magnesium oxide. Right? What we're finding is what happens when that magnesium oxide dissolves in water. Fair? Not a problem? What I want to do now, gentlemen, watch me. You don't learn by watching that for the minute. What I want to do now is to take a non-metal. We're going to take phosphorus and we're going to take sulphur. And I'm going to burn those. I don't want you to do it. And the reason I don't want you to do it is I don't want to fill the room with smelly gases. Right? So I'll do it over here. And the other thing is that I'll do it I will do it in a fume cupboard. And I'll do it the fume cupboard so any excess fumes go out into the atmosphere. Righto? So over here, now, what I'd like you to do, the people up the back, if you can come up to here please and share the seats over here, or maybe come around the front. Turn the fume cupboard on so that we won't fill the air with noxious fumes. The other part of the problem is This little spoon is called a deflagrating spoon. Deflagrating word is a word meaning burning, right? It's got a lid on here that fits over the top of the gas jar, right? So I'll start it burning. And phosphorus burns with a white smoke. Keep it burning in there. Right? Now what will happen is the white smoke, you got a white powder before? The white smoke will now dissolve in the water. What happens when the white smoke? It's gone red. What colour did metals go? When metals burnt, they formed a white powder. That white powder dissolved in water and made the universal indicator go blue. The non-metals burn in air to form a white powder. That white powder dissolves in water to form a substance which turns that indicator red. That indicates that the substance is an acid, right? For some reason, only one person did it? I got the coughs. For some reason they call that white powder there, it's an oxide. It's called an acidic oxide. Why is it called an acidic oxide? Because it dissolves in water to form an acid. Right? Let's do that one. I'll put a bit more in so it's a bit more obvious. Second one is that this is another non-metal. And I want to watch this one carefully. This one smells the worst. Doesn't make rotten egg gas, it forms sulfur dioxide. And sulfur dioxide's a gas that's used in industry, particularly in the wine industry, and the beer industry, to sterilise bottles. It sterilises bottles because it kills any kind of bugs that are in there. Sulphur is a yellow powder. Now, the sulphur... Oh, hang on, what has it done? What's it done?
Melt.
How much heat did it take to melt it? Oh, what does that say about the bonds which are joining the molecules together?
Not very strong.
They're not very strong at all. They're easily broken. Okay? Now, we'll start it burning. It's started to boil now, and it's burning with a what colour flame? Blue flame. Whoops. This is the one that's got to go in there. That's got to go in there because it's got a really bad smell. And the fume cupboard's not working particularly well, and that's a bit of a problem. Sulphur burns in air to form, tell me. Magnesium burnt to form, magnesium oxide. Phosphorus burnt to form, phosphorus oxide. Sulphur burns to form, sulphur oxide. So the fumes coming out the top, dissolves in water to form, make it go red, the indicator go red, it therefore is called an acidic oxide. It forms an acid. How can you tell the difference between, let's try again. If those two non-metals burn in air to form an oxide, which dissolves to form an acid, what do you assume? That other non-metals will do the same thing. For example, carbon's a non-metal. Burns in air to form carbon oxide. Carbon oxide dissolves in water to form an acid. Do we ever use that acid? How many of you have seen carbonic acid? What a load of rubbish. You drink it every time you have a mouthful of Coke. You drink it every time you have a mouthful of soft drink. You drink it every time you have a mouthful of... How do you make any kind of soft drink? Out of, I beg your pardon? What do you do to carbonate water? What do you do to carbonate water? You put into it carbon oxide, carbon dioxide.
Is that like them,
sorry, go on.
the things where you make your own soft drinks with that gas bottle?
How about that? What's inside those little bombs you screw in the top?
Carbon
Carbon
dioxide.
dioxide. It dissolves in water to form carbonic acid, which you love, right? Now, you don't like it as soda water, do you? But you do when you put some flavour in it. Okay, that makes sense?
Yep.
So how do we tell the difference? What's the difference in chemical properties between a metal and a non-metal? Metals burn in air to form a white powder. That white powder dissolves in water to form a blue solution, which is an alkali. Right? That particular alkali is made in there is called milk of magnesia. What do they use milk of magnesia for? It's a medicine given to babies to cure indigestion. Right?
So it's not real strong?
No, not real strong at all. Wouldn't give it to a baby to cure indigestion if it was real strong. What gives you indigestion? Too much. Not too much food. What does your stomach make to digest the food? Acids. So why do you take milk of magnesia or those things? Because it's alkaline that takes the acid away. Right? How do you make an acid?
By burning non-metals?
By burning a non-metal and forming an oxide. That oxide dissolves in water to form an acid. Any questions? Is there a distinct difference between metals and non-metals in their chemical properties?
Yeah.
Yes, there is. Oh, guess what? Nature doesn't go one kind of substance, boom, new kind of substance, non-metal, boom, metal. What do you think nature does? Ladies?
Makes mixture?
It grades. So there are some of those metals on that table over there which have got the properties of the chemical properties of metals and the chemical properties of non-metals, and they're the ones which are in between. They're called amphoteric, and we'll talk about those later on. Okay?
Purple. If you put one of them in, because red and blue makes purple, so it would get purple.
No, if we put some of that in and some of those in, that acid would use up that alkali, and it would go back to being green. Back to being neutral. Okie dokie. Would you like to go to sit down, please? We need to put some stuff in your notebooks. Oh no, before we do that, can you rinse out those beakers down the sink? Rinse the beakers out down the sink, put some more water in it. Rinse them out down the sink, put some more water in it. I think I have to open some windows. Oh no, you don't know, the water's here. Little rinse and change it, just swap some water over. Here we are. Rinse it out. Rinse it out, quick. Put some water in it. Put some indicator in it. Now what do you need to do? Now what do you need to do? We need to burn the steel wool, allow it to burn and then drop that into the water. Okay? Just pick it up in the tongs, give it a... When you pick it up in the tongs, when you pick the steel wool up in the tongs, have it like that, right? Just pinch a little tiny bit at the end, put it in the flame, in the hot flame. Got to open the top. Oh my goodness, give it a blow on it, heat it up and blow on it, over the top, blow on it, blow on it. I turned the heater off, Bunsen off, didn't I? Give it a good burn. Does it form a white powder? Does it form a white powder? No, it forms a blacky kind of powder. Anyone know what that powder is called? Not iron, but we had magnesium form magnesium oxide. Sulfur forms, it's called iron oxide, right? Another name for iron oxide is rust. Put it now into the water and see what happens. See if it changes colour. Give it another heat. Is the ball burnt? Oh. Will now. Okay, now put it in. Stay green? Goodness. Ladies and gents, to me please. To me please. To me please. Did it stay green? Oh. Does iron oxide form an alkali? No. Alkali, metal oxide. Listen time. Listen time. Metal oxides that dissolve in water form alkalis and are bases, right? They form alkalis. Metal oxides which don't dissolve in water are simply called bases, right? They're not alkalis because they don't dissolve. This one doesn't dissolve. Because it doesn't dissolve, what doesn't it do? Doesn't change the colour, right? In fact, what did we say the periodic table was for? Make it easier to learn about elements, righto. See these ones here, this group down here and this group down here, they're the ones that form the alkalis. They're the ones when you burn them, they form an oxide that dissolves in water and makes that water go blue, right, or purple. All of these ones over here, they just burn in air to form an oxide and they don't make it turn blue. That fair? But they're still called, it's a chemical word, we call them a base. Anybody got a problem? Okay, what have we got to work out now? I beg your pardon?
Summary.
We've got to work out what we're going to put in our books, don't we? Right? Do I write that? No way. Who writes that? We do, in a form that you can understand. 12:43. What time does the bell go? Pardon?
Get rid of all
There's
this.
bell sheet over there.
Pardon? Okay. We said that. Oh, where have I put my chalk? Where did I put my chalk? Where did I put my chalk? Sorry, Don. Can we hang on? Can we hang on for a minute? Okie dokie. We're having a lesson videotape. Righto, ladies and gents. Ladies and gents, watch. Metals do what? You can turn the Bunsen's off if you like. Metals do what? No, don't put them, just turn it off. Metals do what? When we heat them up, what do?
They went white.
They burn in air. To form a new substance called an oxide. What have they reacted with? What have they reacted with to form an oxide? Because righto. I won't call it an oxide, I'll call it a metal. What did some of those do? What did some of those do? Dissolved in water to form a... what colour to make it go with the metals? Made it went blue, therefore it forms an alkali. Dissolves in water. form an alkali. That fair? Righto. Non-metals do what? Non-metals do what? Burn in air to form a? No. They burn. Metals burn in air to form a new substance called a metal oxide. Non-metals burn in air to form a new substance called a? Oh dear, oh dear, oh dear. Metals burn in air to form a new substance called a metal oxide. Non-metals burn in air to form a non-metal oxide. Thank you. Because they have reacted with the oxygen in the air, right? These ones dissolve in water to form what? An acid. How do we know? Because the indicator turned red, and when we compare it with the scale it means it's acid. Okay. Therefore, what do we call a metal oxide? What do we call a metal oxide? What's the special word I use instead of alkali? Start with the word base. So this one's called a... And this one dissolves in metal to form an acid, so it's called an... It's called an... It's called an acid oxide. Now, your work to do now, there's the summary. How do we use that to tell the difference between metals and non-metals? A chemical property. How do we use that information to tell the difference between metals and non-metals? Yep.
Burn non-metals, it'll go...
It'll form an? Yeah?
Burn the other stuff, burn the alkaline stuff.
Absolutely. Not a problem. Okay? What have you got? What's your homework? 2 sets. Number 1, describe the experiments we've done. Number 2, make a general statement about what we've just learned. Any problems? Ladies and gentlemen, thank you for your attention. Do you want to go to maths now? You right? What time does this bell go? Soon? About 5 minutes. This is, the writing part is group work, right? This is not me, this is group work. So it's time for you now to get organised within your group to write down what we've learned. Go. Second part of the first part was to describe the experiment. Second part was to say what we indicate, how we tell the difference between metals and non-metals.
Okay.
Sorry, yep. Not a problem. Just rinse it off with a bit of water. Just cut the tap and rinse it off with a bit of water. It's not a problem. There's only methylated spirits on it.
Oh, so it's okay.
Not a problem. Yep.